Okay, road hydraulic and drainage structure. So this is basically the subtopic that we are going to cover. First is the hydrological analysis, and next hydraulic design of structures, surface drainage and subsoil drainage. The first two part is on the analysis and you can say design, not exactly design, but it is the analytical part of drainage provision for road projects, right? So let us quickly go to hydrological analysis. All right, hydrology, right? So hydro is what is hydro? Hydro is basically water, right? Hydro is water, so logy is a study of water. Hydrology. Apa logi-logi, macam-macam lagi kan? So this is hydrology. So the study of water with reference to land and in this case road would be would need what they call your understanding of this, at least these few items here. I list 7, but there could be more. These are 7 major considerations when you want to study the water behavior, especially from rain, when it falls onto the surface of the earth. So the first that is going to affect why we want to study the hydrology, because we want to know how the water flow from its point of contact when it rains, and then how it flow away finally to the sea, or some of them go into the ground, some of them evaporate. So this is how water go away from their point of contact with the earth, right? So the factors that affect the amount of water that go away from the first contact is, one is the catchment area, right? You may have already heard this, catchment area. Second is rainfall. Of course, the rain itself, you're talking about today in the morning we have had quite a heavy rain, and then compared to yesterday, for example, maybe slightly different intensity of rain. So the rain will also affect the amount of runoff. Runoff is the amount of water that flow after, especially after rain. The third one is the topography. Topography is the landform. Very steep hill, very narrow catchment, very big catchment. The shape of the catchment, the size, the length, and so on. So that will determine the topography will determine probably your catchment shape, right? Not just the area, but shape. And then vegetation and soil. Why vegetation and soil is also one of the factors that affect runoff, because the different kind of soil absorb water differently from the rain. And vegetation, if you have a very heavy covered vegetative trees, you may have a lot of leaf, tree leaf that will capture some of the water, and then the water later on will be evaporate to the air, and so that water will not be touching the ground. So that's why. And of course, the catchment shape I mentioned just now. Number 6 is the available storage. Storage means why storage is also another factor that affect the runoff. It is because it will influence the amount of water flowing out from the place where it rains. For example, if it rains here in this room, without any storage, the water will all go away through this door. All of you will go through out for this door. But let's say there is some pond here. Some water will be remaining in the pond, and the rest of the water will go away. Right? So the amount of water that went out just now will be plus this amount if we don't have this storage. So that is why available storage. So that will determine the amount of water that goes out from this door. And of course, number 7 is degree of urbanization. Why degree of urbanization? Because urbanization will cause the soil to be covered. Water cannot go into the soil. You can cover the soil, for example, with concrete like this, so no water, 100% of water go away. Partially covered, for example, this building outside there is some slope, there is some green area, bawah tu ada jalan. So the percentage of impermeable layer in the urbanization will also affect runoff. So that's how all these things, these are the main factors that affect the amount of water, the amount of runoff. We call it runoff, right? Runoff. So this is the first step of us trying to understand the behavior of water flowing, for us to be able to provide what is needed or what is required to manage that, right? To manage the amount of water that is what we call runoff. So the hydrology part here will be able to tell you what is the quantity of water. Okay, let us go quickly. The catchment area, right? The first factor, right? This is the catchment area. So this is the shape. For example, this is the shape of this area. But if this hill look different, so the shape may be different. So it depends. And when we talk about catchment, you must keep in your mind this term, what we call watershed boundary, ataupun catchment boundary. So these are some terms that will be used in the conversation in the technical meeting, for example, of land development, as definitely including road. Watershed boundary is a boundary of when it rains, all the water will go to certain point. For example, in this case, all the water within this catchment boundary, within the red dot dash catchment boundary here, will go to this channel and finally go to this main river and finally go to the sea. And so it goes to one point at this point here. So if the catchment, the so-called catchment, can have what we call sub-catchment, meaning sub-boundary. So you will have sub-boundary like the blue one here, right? So the blue one here will finally discharge all the runoff at this point. The red one at this point. So if you break the catchment further, you will have another small sub-catchment, right? For example, this river here. Okay, it can have its own catchment here, catchment here, catchment here, right? So that's how we determine the amount of water from runoff that is coming out from the various sub-catchment and finally the big major catchment. Why do we need to look into the sub-catchment? Because some structures, like we are talking about drainage structure, some drains are in the sub-catchment. For example, your house, you have a bungalow house in some residential park. How much water is coming from your plot? You may have a 1/2 acre bungalow. So the 1/2 acre, a rain that fall onto that 1/2 acre will need to be determined. How much are they coming out, so that you know what is the size of for example, your perimeter drain surrounding your house, or finally and then is the perimeter drain going to be bigger? One is go near to the main road, for example. So you may need a bigger drain once you approach the road, because it has been collecting a lot of water from the end of your house to the front and then finally to to the frontage, to the road. So that's why we need to divide this catchment into sub-catchment. So, for us to be able to determine what is the amount of water, and then what is the hydraulic structure that need to be provided. We will talk about what kind of hydraulic structure we provide in road project. All right? Drain is one of them, definitely. Culvert. It is the most common structures in road project. Summer, catchment. I mentioned just now, catchment. You have catchment area including road like this, 100% of the water will go to the drain. We will come back to this picture later on when we do hands-on calculation in the calculation part today. We'll come back to this one. And rainfall. You can see now is, we expect a lot of rainfall between October and December, but the Met Malaysia even say this year we are going to have even more rain during November and December. This was in what year? I don't have this. This was historical data of rainfall. You can see the rainfall. Most of the time, the rain will be. We have got more rain during March to June, and then from September to December. Right? Those are the two monsoon seasons in Malaysia where we have more rain. And then we expect in January to be less rain. So I hope this coming January we are going to the site. There will be, the site will be easily accessible. Right? Easily accessible. So rain. This is rain. Where can you get this rain data? You need all this data for you to do the assessment. Rainfall data you can get definitely from Malaysia, right? But if you're talking about road and drainage in development, you want to get this data from JPS, Jabatan Perparitan Saliran, ataupun DID, Drainage and Irrigation Department from Malaysia. But of course, you can get from Malaysia. Why it's better to get data from JPS? Because in land development, road development, and so on, we refer to JPS manual to design drainage system. So it's better because when they give you example or guide in the manual, they will be referring to their own rainfall station. But if you want to study, for example, a weather study, environmental study, for example, then Met Malaysia data can also be used because Met Malaysia has got a lot more data than rain. It has got data like temperature, not only temperature on the ground, on the surface, 1 meter above, 2 meter above, and so on. They have a various category of temperature. They also have other wind data from Met Malaysia. So you have a lot more data, what we call environmental data from Met Malaysia. But for road and drainage design, for our purpose, we will be looking at DID data, especially for rainfall. So you can see when it rains, in this case, all the water will go into the drain. This is not very obvious, but where do you think this road is turning? To the right or to the left? It looks like it's going to the right, right? So when it's turning to the right, the road level will be tilted a bit to the right. Because bila you pusing membelok ke kanan, jalan dia akan menyending ke kanan. So what happened when it tilted to the right? The water has to go somewhere. So that is where you need to provide the drain. Otherwise, the water will go to the next highway, the opposite side of the highway. So you need drain in the middle, right? If this is going to the right, then you have to have drain here. Otherwise, you go to the other side. So that's where we provide drainage system in road. That's one example. There are a lot more. Of course, what happens if the road is straight? Where does it tilt to? Left or right? Yeah, you go to left and right. Right? That's when we need what we call roadside drain. Right? Because the water go to the side of the drain. So we need the roadside drain. In this case, it looks like all the water will go this way. Right? No water go that way. So there is no drain on this side. because all the water go here. But if it's straight, then you go to left and right, then you will have your drain on the left and right. Okay, that's rainfall. I need to do this quickly because we are going to have a hands-on today. Do some exercise because we are talking about hydraulic structures and calculation. So there will be need calculation lah. Topography. This is a topography. You can see, I mentioned already just now. I think you have got it. Again, topography, something like this. The time the water need to flow from up here to down here will be definitely different from here to here, for example, because this is a steep slope. This is a mild slope, right? Mild slope. Anyone from here? Nice place. Anyone from Cameron Highland? Last many years, my colleague from HDP, lecturer, but he left, was from Cameron Highland. So he always organized a project, student project, and go to Cameron Highland and stay at his father's house. Because his father is a penghulu, somebody there, so they have got a big house. All students go into the house. Storage, I mentioned storage, right? So storage, you can see, for example, this is the green area. This is where we provide a lot of storage because this area is very sensitive to flooding. We don't want it to be flooding. This is the first phase of Kulim High Tech Park, if you know, in Kulim, Kedah. When it was designed, we provide a lot of main drain. The blue one is the main drain. The main drain that goes out from the site. This is 140 hectare, which is about 300 acres. And then this way. So in between, we will have a lot of storage. In those red dot are the storage. So whenever it rains, the water will be first stored in this what we call storage system. So it will not go away. So we will not disturb the surrounding kampung, surrounding town. For example, Kulim is to the south, and the most kampung are to the northeast. So even though there are main drain systems that are coming to the south and to the north, but they will not cause any disturbance to the existing situation in the nearby area, because we provide a lot of what we call storage system. Otherwise, there will be a lot of water coming out from the site, because you remember I mentioned before, the type of the trees are cut down, become a hard surface, and all water will be going quickly outside from the site quickly, and then that can cause major flooding and things like that. So this is some example of pond that can store water. It can be wet pond or dry pond. All of these are wet pond, which is also used as wet pond. Is the water will remain there at certain level. When it rains, it go up to certain level, and then it slowly go out, and then come back to the original level. A dry pond is a pond where it's dry. You can play football, for example, on that ground. But when it rains, it contains water. But and after a few hours, the water goes away. So that's dry pond. This is wet pond. And most developers would like to have a wet pond because they can also be seconded as what do you call it, landscape component in the development. Of course, if you have more green, the place will keep more water. I mentioned just now. You can see vegetation and development, even development for the agriculture itself. You can see if you clear the area, it becomes like this. And compared to this, right? This can hold more water than than this one here because it has got no grass and things like that to keep the water in. So that means with this kind of landscape, you have more water going out. Not only water, but you also bring out the soil particle that give you what we call sometimes the muddy flow and things like that. So that can happen. Not only the quantity of water is increased, but it comes also with the quality of water. Quality. When urbanization happens, this is not going to happen. Especially a road project, all the water will need to be considered. No water will go into the ground because it just cannot go into the ground. So, now we want to be able to determine how much water, right? Because of those things just now, because of the slope, because of the catchment area, because of the clearing and with and without trees, with and without road, for example, steeper slope, milder slope. So, how do we determine what is the amount of water? Okay, the amount of water that we determine for us to prepare this hydraulic structure depends on the risk that you are willing to take. Because you cannot be providing structures that will last forever, will never be overflow, things like that. That costs a lot of money. So you need to be able to assess the risk. What kind of risk can you take? All right. So that's why you need to know what is the amount of runoff that you want to consider as design value for you to choose certain hydraulic structure for your road, right? Example, is it okay for the road to be flooded every year? Kalau tak okay, then you need to choose other criteria. That criteria is basically based on the amount of rain. So that means you will design the drain that is taking away water from the road. The size of the drain, because the size of the drain will affect the cost of our project. Orang kata, last time I did a project only certain juta. You buat projek kat mana? Kat kampung. Kampung okey lah, air pergi atas. You buat kat pekan mana? Air masuk dalam rumah taman habis. So that kind of thing. So it depends on the risk that you are taking. So we need to know what we call here two things. One is what we call average recurrent interval. Average, okay? Average. You can recurrent interval. That means we rate how frequent rain that we have today will come again, like what we have this morning. You say frequency is every 24 hours, meaning tomorrow we expect it to happen, and afterward. If you say, okay, is that kind of rain probably once a year, so that once a year. So that's that intensity of rain, and also duration. Intensity, very very heavy, and duration, how long? You can say, oh, this kind of rain I've never seen in my life. You know, you talk to your tok wan, dia kata, oh, tak pernah hujan ni, macam ni. Dia kata, kalau macam ni, esok air sungai naik, mungkin lah kan. So that kind of thing lah. So that is the kind of rain that we will call, what we call average recurrent interval. What kind of recurrent possibility is going to happen? So this is annual accidents probability. This is similar to this. So these two consideration will be taken into consideration. These two things will be taken into consideration when we decide on what we call design. We call design flood. Actually, bukan design flood. Design value lah, value of rainfall. Because selalunya bila kita buat drainage structure ni, we're talking about avoiding flood, right? So that's why we call design flood. So menang kalau kita ada design flood for 10-year design flood, that means no flood will happen, no overflow will take place because of this drain. In 10 years, more than 10 years, it may happen. That's the kind of what we call design flood that we are talking about. Tapi that it does not necessarily mean that when you say 10-year design flood, for example, I do my project today, I say, okay, this drain is designed for 10-year design flood. Suddenly, 2 years after after today, it overflow. Remember, the 10-year can be 5 years back and 5 years. It can happen. It can have the chances to happen is 10 years, but it can happen now and next 10 years, right? It can happen 2 years from now and another 10 years. So we don't know, right? So that is the likelihood for the rain to happen. So in construction, in our road project, so this is the kind of what we call ARI, or average recurrent interval we use when we provide road hydraulic structure. We're talking about, okay, bridge. First is bridge, okay, jambatan. Definitely, if you have a road project, you will have some kind of jambatan. So for jambatan, we need to consider 50 or 100 year ARI. Meaning we cannot afford for the jambatan to be over by water with 25, 50 or 100 years. It depends on the category of road, right? Because U is urban road, R is rural road, right? So ada U2, U3, U4 and so on. This is the category of road in Malaysia. Later on, or maybe you have already, Puan Syatina or Liza already mentioned this to you, but definitely you will be exposed to this road category in this class. So for bridge, it's very critical. We don't want it to be flooded. And second is culvert. Culvert is that component that if you have road here, you want to bring water from my right to my left, you want to cross the road, so it has to go cross using the culvert and below the road. So that's culvert. For culvert, it would be 20, 25 or 50, depending on the road category. Some road, in some rural road, for example, category R2, you can afford to have 20. Slightly more urbanized area, you have 50. Right? 50. So the chances to happen is every 50 year, every 20 year, every 25 year, that kind of thing. Because you cannot be providing the same thing for all road, because it costs money, right? Costs money. Or you want to provide some structure that forever can, then that's too much. That's uneconomic. Not economic to do that. Road surface drainage, 5 to 10 years. Road surface drainage. Road surface. So maknanya you don't want the surface of the road to be flooded. You can allow some flooding, but not less than. You want to at least the road to be free from water. Only 5 years. Mungkin sometime it will happen. Intercepted drain is a drain that intercepted drain. Later I show you intercepted drain in illustration. Intercepted drain is basically you have a slope like that, see, coming down. So dekat kereta tu, just before the slope, we will have a drain, right? So that no water from atas sana turun bawah. So that is intercept. So the drain will intercept any water from up there coming down. So that is interceptor drain. So, for you to be able to do some analytical work on the amount of water that is going to be flowing, that will affect your road or not necessarily log anything, the surface of the earth. This is the most common approach for you to analyze that. We analyze that using what we call a rational formula. Okay, a rational. This formula is called rational formula. This is a formula that has been established long time ago. The formula is very easy. Q, right, equal to CIA. Q, CIA. Right. Q is the runoff, the amount of water that will flow out through this door. If you rain here, water coming out, that's the Q in meter cube per second or feet cube per second, right? Depending where you work. But most of the time, I think most of us will be using SI unit, right? And then, what is this here? 360. CIA divided by 360. Why? The basic, the formula is CIA. The Q is the runoff. The C is the what we call runoff coefficient. Runoff coefficient will take into consideration the type of land cover, whether it is, for example, a grass like that, whether it is a road like that, whether it's a building like this. So that's the C. We call it coefficient. So that you can refer that coefficient. You can refer to this any document for hydrology, including what we have here in Malaysia, the MASMA, Manual Sarian Mesra Alam by the JPS, or any hydrology textbook in Malaysia. The I is the rain. Remember the amount of rain? So I is the intensity of rain in millimeter per hour. In 1 hour, how many millimeter of rain? Why millimeter? How do we know millimeter rain? Because our rainfall station, remember we have rainfall station all over the country, and I think USM we have one rainfall station. Bila? Okay, boleh pergi tengok kot dia lah. Ditanyalah siapa-siapa, dia boleh pergi tengok rainfall station. Because this rainfall station will measure the amount of rain in millimeter or inches. So now it's millimeter. So that is why in the intensity is millimeter per hour. In 1 hour, how many millimeter of rainwater is collected in that measuring equipment, right? So that's the mm. So when there are heavier rain, definitely the mm is higher, right? So that's normal. And these days, all these are what I call it real time. If you go to JPS or go to Met Malaysia, you can get this data per hour. And what is A? Remember just now the catchment area. Yeah? The bigger the catchment, of course, more water. That's why it affects the Q. Alright, now come to what is this 360 here and what is 0.278 in front of the CIA here. That is just a conversion factor. Alright, depending on what kind of formula you use, what kind of not criteria, unit that you use. The one down here, the unit for area is in hectare. That is standard international, right? The one up here, the unit for area is in kilometer square. That's the only different for this case. Hectare, you divide by 360. You use kilometer square. You multiply by 0.278. Okay. But the basic formula is CIA. Originally, it was just CIA, nothing else, because it was developed in English unit, which is feet cube per second. So when you use feet cube per second, area is in acres. It will and the intensity is inch per hour. Then there are no conversion factor. QCIA terus. But we don't use that unit right here in the current practice. Originally, it was just CIA. So this CIA will give you the amount of water. Why you need to know this amount of water? Because you need to provide the drain, the size of drain. Ataupun kalau you nak nak tuang ayat teh, you nak tahu berapa banyak ayat teh yang nak tuang dalam cawan saya. Cukup ke cawan ni? Things like that. So you want to mesh them. Later we will see how we mesh the amount of water and the size of the drain, for example. Okay, so this is where sometimes we can get the rainfall intensity. Usually it's already provided in the form of charts like this by the authority. For example, the GPS will have this kind of thing, but you can also generate them from your data. But we will skip that one. But at this time, you need to be aware that there are information like this available that give what they call it a chart that give you rainfall intensity and what is the storm duration. If you know the storm duration, you can get intensity. Then you can use the I in the CIA formula. Okay. And the duration itself, actually, there is a calculation to find that duration. For example, what rainfall duration? 30 minutes, 50 minutes, half an hour, 2 hours, 3 hours. That duration. How do we determine that? That is another what they call, probably the next one. Yeah, this is intensity. This is the okay. If you don't have that chart, you need to calculate by yourself. This is the formula, right? To get the intensity. This formula is in the JPS document called Manual Saliran Mesra Alam. And you need this coefficient for that formula just now. Remember just now you see that formula? Intensity equals to lambda T is K and divided by D theta N apa tu? That is a Greek word, I don't know. But where do you get that? This is also from the JPS manual. This detail. Once you have got this detail, it depends on where is the station. So you're talking about Penang or USM, you have to find the USM. For example, in Penang, we have, over here I have 9 stations. Simpang 4, air besar, kolam tangki, komplek pra, klinik, benet, kolam bersih, sungai ibu bekalan, lahar ikan dan sebagainya. So these are the stations. So depending on where your site is, you need to be referring to the nearest station. Okay, now next one is the coefficient, C, right? The CIA, right? So this is a C. So different kind of place, for example, residential area, they have different C. Sports complex, C. Open space, road and highway, for example, remember, we're talking about road and highway, 0.95, the C. Because by right, it should be 1.0. Tapi somehow, maybe we expect some of the water to be evaporated away, or that's why just 0.95. Retention pond, when you have pond, definitely all water, whatever water coming in, it cannot go away. There's a amount of water. Detention pond with outlet. But if you're talking about retention pond, then 0. Retention means, retention and detention are two different things. Detention pond is a pond, storage that will temporarily store the water. After that, it will release the water. A retention pond is a pond where you let the water go into underground, seep into the ground. So no water will flow out. You collect the water in here. You will never discharge them outside, but you let them go down. So that is a retention. So that is the difference between detention and retention. Okay. Remember, just now I was talking about duration. What is the duration of rain should you use to, if you want to read the chart just now, or you want to use in the formula? So, this is the formula of what we call rainfall duration, or what we call sometimes time of concentration. It is the same as rainfall duration. Time of concentration, meaning time of rain, or rainfall duration. But in certain situation, the catchment may be very small. So the minimum time of concentration to be used in your calculation is, or to read the chart is for road inlet, you see, rainfall, and it goes to the roadside drain. The minimum TC is 5 minutes. For small area like your house, just 10 minutes, right? Any area that less than 0.4 hectare, which is 1 acre, right? 1 acre. Any area that less than 1 acre, the time of the time of concentration or rainfall duration that we use to read the chart or to use the formula is 10 minutes. There are also other formula that you can use, something like this, but that was just now it was the most common formula that we use. Of course, sometimes we already have this chart. You just need to find what is the duration, then you get the intensity. Okay, rainfall intensity. This is one example for a project. This one is in Kedah, Alostar, where we calculate the rainfall intensity, right? Intensity according to the formula, and then finally we calculate the Q based on CIA, right? And this was divided by 360 because the area is in hectare, right? So finally we got a Q, in this case for 100 years, ARI, that's why Q100. So the flow here, we expect after project the flow will be 4.6 meter cube. Before the project is taken place is 3.5. So there is an increase in the flow going out this door. So something needs to be done. We need to maintain the amount of flow that coming out from this door. So there need to be some recommendation on what to use. Tadi one of them is storage kan. Okay, so that is the first part.